Assalamualaikum warahmatullahi wabarakatuh. Today I want to present about the nuclear technology in transportation. Okay, my name is Danial Iman Bin Norazam and my matric number is 1212948. Okay, so what is the nuclear energy in transportation? It is used nuclear fission to generate heat, powering propulsion system, and electricity for vehicle, ship, and train. So for the energy production and propulsion, it has high energy density that allows long distance travel without frequent refueling. So it is frequently used in submarine, aircraft carrier, and electric train. Okay, next, how about the efficiency when using nuclear energy? The small amount of nuclear fuel generates significant energy that can offer higher efficiency compared to traditional system. And then the growing interest in clean energy. Nuclear power provides a low emission, high performance alternative to fossil fuel, and it is essential for the future of clean, sustainable transportation. Okay, next, how the nuclear energy works in the transportation. So for the basic principle, nuclear reactor used to control fission to produce heat, which is then converted into electricity or propulsion. So for the energy production, heat generated by nuclear fission power by turbine, either in marine vessel, which is submarine or ship, or land-based vehicle, train or aircraft. So for the core process, we'll start with fission, then produce heat, then we'll produce steam. Then from the steam, we'll move the turbine, and from the movement of turbine, will produce electricity. Okay, next, what is the benefit when using nuclear energy in transportation? First of all, it has high efficiency. Nuclear reactor provide a high energy density, meaning less fuel is needed compared to conventional system. And number two, long operation period, which is nuclear power system can operate for years without refueling, reducing the maintenance and downtime. So for the third one is reduce emission. So the nuclear energy produce significantly lower emission compared to fossil fuel, contributing to cleaner air and less environmental pollution. And lastly, the energy security. Nuclear energy can reduce dependence on oil and other external sources of energy. Okay, then despite all of the benefit from using the nuclear energy, there are also challenges that we might face when using it. So for the first one is the safety concern, which is the risk of radiation, accident, and nuclear proliferation. This is the primary challenge for public acceptance. For the second one is nuclear energy has high cost in building and maintaining the nuclear reactor, including the decommissioning costs. So for the third one is the waste management. So handling and disposing of nuclear waste safely might face some challenge and effectively remain an ongoing issue. So for the last one is public perception. Nuclear power often faces resistance due to fear of accidents. Okay, next we move to the type of usage when using nuclear energy in transportation. So there are two types, which is direct use and indirect use. So for the direct use is nuclear reactor are integrated into the vehicle, providing a continuous power source. So it is often used for propulsion, which is movement, and onboard electricity generation. So the full use is the uranium-235 for controlled fission reactor. So for the benefits is the extended operational range, high energy output, and independence from fossil fuel. So for the next one is the indirect uses, which is the nuclear energy is used externally to generate electricity, which is then supplied to transport system. So the fuel used in this type is plutonium-238 in RTG and uranium-235 or uranium-238 in nuclear power plant. So for the benefits when using this type of uses is reliable energy supply, reduced carbon emission, and long-lasting power for deep space mission. Okay, next for the key nuclear element used is the first one is uranium. Uranium is the primary fuel used in nuclear reactor, specifically uranium-235, which undergo fission to release energy. And next one is plutonium. Sometimes plutonium is used in reactor, especially in certain type of reactor designed for long-term operation. And the last one is thorium, which is the future potential of nuclear energy. It is an alternative to uranium with potential for safer and more efficient reactor. So for the application of nuclear energy in transportation for the direct use is USS Nautilus. So the USS Nautilus was the first nuclear power submarine. It was launched by the US Navy in 1954. Its introduction marked a major milestone in naval technology, and it was a symbol of the potential of nuclear power beyond electricity generation. So the nuclear propulsion technology was used in this USS Nautilus. The submarine's nuclear reactor power the propulsion system, allowing it to stay submerged for much longer periods than conventional submarines that relied on diesel engine. The innovation that has been made from the USS Nautilus is the USS Nautilus success proved that nuclear propulsion was feasible and more efficient than fossil fuel power system. In specific application like submarine, this led to the development of other nuclear power vessels, including aircraft carrier, submarine, and surface ship. The US Navy currently operates a fleet of nuclear power submarine and aircraft carrier, showcasing the long-term, cost-effective advantage of nuclear technology in maritime defense. So for the impact from this USS Nautilus is the technology innovation. The successful deployment of nuclear power in naval vessel was a precursor to broader civilian application of nuclear energy, including those in electricity generation and later certain transportation system. And the second one is operational efficiency and safety. The technology demonstrates that nuclear power could be harnessed for reliable, high-performance application, reducing the need for constant refueling and maintenance. This also proved that with proper safety protocol, nuclear technology could be used safely in operational movement. For the second application is train à grande vitesse, TGV. TGV is the French high-speed train that not directly powered by nuclear reactor. France's use of nuclear energy for electricity generation significantly supports the TGV system. France is one of the world leaders in nuclear power, with 70% of its electricity generated by nuclear energy. So for the energy sources for TGV is the electricity. And since France's electricity is predominantly generated by nuclear, the environmental impact of TGV operation is drastically reduced. The carbon footprint of operating this high-speed train is much lower than that of fossil fuel power train. So for the innovation from the TGV is there have been experimental concept and prototype for nuclear power train. Although none have been fully realized, ideas for nuclear propulsion for high-speed train have been explored, particularly in regions where energy efficiency and sustainability are top priorities. So for the impact when using it is the sustainable transport. The use of nuclear-generated electricity for TGV operation play a key role in France's effort to reduce carbon emission from the transportation sector. And the next one is efficiency and speed. The TGV operating on nuclear-derived electricity is able to provide exceptionally fast, reliable, and energy-efficient service over long distance. It is one of the most energy-efficient mass transportation system in the world. So, in conclusion, nuclear technology has played an important role in advancing transportation, especially in marine and experimental rail system. So, for the future potential is the innovation in nuclear technology may open up new possibilities for long-distance, low-emission transport system. That's all from me. Thank you.